Hello, welcome back. Oh, set my watch. As I'm setting, I'll talk to you. Hope you don't mind. My name is Susale Mohana. I am an experienced teacher who's taught A-level maths for over 50 years. And I'm doing this just to share whatever I know with students like you to help you go over what you learned in school and prepare for your exams. All right? Okay. In the last lesson, I did questions on integration by parts. Now I'm going to do harder questions on integration by parts. I think your syllabus says not more than 3 applications of integration by parts. Not more than 3. Okay. Let's take okay. Integral ln x the whole cube dx. And on the other hand, I'll say integral ln x cube dx. There's a big difference between the two. Do you notice that? L, A, T, E, C. I have an L. I don't have a C, so I'll put a times 1 and I call it a C. C is 1. Okay. So your U is ln x the whole cube. dv by dx is 1. So your du by dx is 3 times ln x the whole squared, onion rule. You first differentiate the cube, keeping ln x as it is, then differentiate ln x. When you differentiate ln x, I get 1 over x, and v is integral 1 dx, which is x. So it is u times v minus integral v times du by dx. The x and x cancels. So it is x ln x the whole cube minus integral 3 times ln x the whole squared dx. Again, that is a constant, that is L. So u equals ln x the whole squared dv by dx equals 3. I don't want to go through the whole process, so I'll just write the answer straight away. So it's x times ln x the whole cube minus u is ln x the whole squared times v is 3x minus integral v is 3x. ln x the whole squared gives you 2 ln x and ln x gives you 1 over x dx. Keep on opening the brackets and simplifying. So x times ln x the whole cube minus 3x times ln x the whole squared plus minus a plus here. Look, the x and x will cancel, plus 6 integral plus integral 6 ln x dx. So again, u equals ln x, dv by dx equals 6. So the answer becomes, where shall I write it? I think I'll write it here. I'll write it here. Equal to x times ln x the whole cube minus 3x times ln x the whole squared plus 6x times ln x minus 6x plus c. I'll leave you to figure out how I got the last bit. At each stage, apply integration by parts for that, apply integration by parts again for that. That means I have applied it 3 times. Here again, a bit of algebra will tell you ln x cube is 3 ln x dx. That's a C, that's an L. Only one application of integration by parts. So U is ln x, du by dx is 1 over x, v is x cube, oh sorry, dv by dx is 3, idiot. So v is integral 3 dx, which is 3x. So it's in u v. So 3x ln x minus integral 3x times 1 over x dx, which is 3x ln x minus 3x plus. Much easier. So if you keep on repeating, in other words, that's where the beauty of LATEC. At each stage, if you're doing integration by parts, use LATEC, life becomes much easier. Okay? So life becomes easier. That's wrong English. Yeah? Okay. Let me take a very interesting example. The third example, because I've done 2 today. The third is integral. Let me see if I can make up the question. Integral e power 4x sine 3x dx. Right. LATEC. I have an exponential, I have a trigonometric, e comes after t, so u equals sine 3x, dv by dx equals e power 4x. Simple. In this question, it doesn't matter if you were to call that as u and that as dv by dx. Sorry, this as u and that as dv by dx, it still works. Alright? Only if it is exponential and trigonometric. So du by dx is 3 cos 3x. V is integral e power 4x dx. E power 4x gives you e power 4x. 4x gives you 4. So it becomes, let me write this as integral e power 4x sine 3x dx. Should I write that? I think this portion of the board gets camouflaged, so I'll write here. So integral e power 4x sine 3x dx equal to u is sine 3x. So e power 4x over 4 times sine 3x minus integral e power 4x over 4 times 3 cos 3x dx. Well, there's nothing I can do there. I'll keep it as it is. Minus 3/4 integral e power 4x cos 3x dx. Again LATEC, otherwise you used u as sine, got a cos. So u must be cos. You use e power 4x, got e power 4x. So dv by dx must be e power 4x. Otherwise use LATEC, so you get the same answer. So u equals cos 3x. So du by dx is minus 3 sine 3x. dv by dx equal to e power 4x. Therefore, v equal to quarter e power 4x. So it becomes quarter, let me write here, quarter e power 4x sine 3x minus 3/4 times u is cos 3x times e power 4x over 4 minus integral e power 4x over 4 times minus 3 sine 3x dx. Let's open the brackets and write everything. So integral e power 4x sine 3x dx equal to quarter e power 4x sine 3x minus 3 over 16 e power 4x cos 3x. Minus and a minus is a plus, plus and a minus is a minus. 3 times 3 is 9. 9 over 16 integral e power 4x sine 3x dx. Now, remember I need to continue till I get rid of the integral. I apply integration by parts again. E power remains e power, cos becomes sine. I apply integration by parts again. E power remains e power, sine becomes minus cos. Boom. I keep on doing. I hand it over to my son. He does it for another 20, 70, 40 years. He hands it over to his daughter. She does it for another 40 years. She hands over to her son. And he is not a mathematician, so he gives it to his wife. She continues, and then their child continues, and their child continues. For the next 10 generations, they keep on working in the same question. The integral never goes. So what do? I'm stuck, aren't I? This method, which I'm showing you now, is called the method of reduction. What is this? Integral e power 4x sine 3x. Suppose I were to call this as I. So can I say I equal to, between these two, can I remove e power 4x over 16 as a common factor? I get 4 sine 3x minus 3 cos 3x minus 9 over 16 I. There is an I on the left, there is an I on the right. What can I do? Group the I's. So what happens when you group them? 1I plus 9 over 16I is I plus 9 over 16I. So I can rub this off now. I have 25I over 16 is equal to e power 4x over 16 times 4 sine 3x minus 3 cos 3x. So I, which is integral e power 4x sine 3x dx equal to 1 over 25 e power 4x times all that. Right? That's an interesting question. I like it. Hope you liked it. There's just one more standard question which I will do. Remember when I did trigonometric functions, I said any power more than 1 of tan or cot, but when it came to cosec and sec, I talked of only even powers of sec, even powers of cosec. Why? I'm taking an odd power. For example, I think is it example 5? I think so. I don't know. Integral sec cube theta dt. I can't integrate it. We use the same reduction method. So what we do is split into, let's call this as I. Sec squared theta times sec theta dt. Yeah. Okay. Now, I can integrate sec squared theta, but if I integrate sec theta, I'm going to get an ln. So it's better I differentiate. So u equal to sec theta, dv by d theta is sec squared theta. So du by d theta is sec theta tan theta, and v is integral sec squared theta d theta, which is tan theta. So I equals u v minus integral v du by dx. So that is sec theta tan theta minus integral sec theta tan square theta d theta. Sir, can we use integration methods again? Yeah, but you can't integrate tan squared. So if you're going to integrate the tan squared, you're going to get a sec squared minus 1. That means you had differentiated the tan squared you got from the tan. So indirectly, you are going backwards. So you can't do that because you're going back to the original question somehow. So what we do is, we have learned identities, haven't we? Tan squared theta is sec squared theta minus 1 d theta. So that's minus integral sec cube theta minus sec theta d theta. Correct? So therefore, I can rub this off. So that becomes, so I equal to sec theta tan theta minus integral sec cube theta d theta plus integral sec theta d theta. We got a minus here and a minus there makes it plus. This is also I. So 2I equal to sec theta tan theta plus, when you integrate sec theta, I get ln mod sec theta plus tan theta. So therefore I equal to, which is integral sec cube theta d theta equal to half sec theta tan theta plus half ln sec theta plus tan theta plus C. That is the only way you integrate sec cube theta. That's almost 17 minutes. Alright. So I've shown you some interesting examples of application by integration report. Let me look at the questions. If I have more interesting questions, I will take up one more lesson. Yeah. Interesting. I think so. So, no, I think I'll stop at this stage and I'll spend some more lessons. In fact, the next, yes, I would like to do some more, but for people from OCR, I think, and maybe AQA who have derivatives of inverse functions included in their syllabus. So Edexcel people, if you're doing further maths, join in the next lesson. If not, if you're following the lesson every lesson, you might want to skip the next lesson. Okay? Right. Otherwise, of course, you're welcome to knowledge is never a waste. So you can always attend and learn more. I'll see you in the next lesson. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.